Hello guys, welcome to this session to solve another problems. We want to solve problem number 358, but as always let me introduce our reference. This is fluid mechanics from Mr. Streeter, Wiley and Bedford. You have to have a 9th edition of this book to solve our problem. Then let's go back to our problem. Page 175, problem 58. Calculate the average velocity and momentum correction factor for the velocity distribution in a pipe, like the formula like this. Then y is the wall distance and RO the pipe radius. Okay, let's go to Byteboard and solve this problem. Okay, first I want to draw a cross section of a pipe and put our parameter on that. This is RO or R0, not different. We called it I'm gonna call it RO because this is it's a better name for that, to call it. Okay, and let me just separate element of the A from that. Okay, the thick of this is dr, and this radius between middle of the R is R. Sorry, this is R. Okay, I can write the A equals 2p RDR. Okay, this is the area of this element. And if we look at this view to this pipe, we can see something like this picture. Okay, if this dashed line is wall, then we have a center line here. Okay, this R is RO, as I introduced it before. If I put, for example, a point here, from this point to center line is R as I introduced it before, but from this point to top wall, to the wall, is Y. Okay, from this line, center line, to this point is R, from this point to the wall is Y. Then I can write this equation for that. r equals ro minus y. Okay, it is so useful to when I want to integral from the formula. So, and with the color red, let me write the formula that the problem said v max, this is new velocity, this is maximum velocity, equals y over ro with power of 1, and n is a constant. We don't know what is it, but we know this is constant. So I know a formula for knowing average velocity. In this session, I want to just find average velocity and momentum correction factor. Momentum correction factor will be remain for another session, or you can do it by yourself. I just want to find my average velocity. Okay, multiplied by a, I can write this equation, integral of nu a over dA over a. Okay, it means any velocity in any element multiplied by that area would be something like that, would be equal. If I have average velocity, I can multiply it by whole area of that. But this is precisely and I have to find average velocity from this formula. Okay, let's do it. I can write 1p r2 because this is a. Okay, but let me first introduce it to you mathematically. Okay, then I can write average velocity equals 1 over a integral v dA over a equals 1p r02. Okay, it is okay. Let me write it. I should put this formula in place of v. Okay, it is v max y over ro 1n 2p r dr is in place of dA. Okay, place of dA, and this is in place of v. Okay, let's continue. This p will eliminate this p. I have 1 r2 integral of a max r g ro minus r ro. If I multiply, if I put this equation, y would be ro minus r. I'll put it in place of y. Okay, with power of 1 and 1 over n 2 r dr. It is equal to the max r o square multiplied by r o power of 1a. Why? Because of this ro, this is power of 1n and come out of integral, because ro is constant and is constant, both are constant. I can put them out of integral. Then integral from r is from 0 to ro RO minus R N R dr. Okay, I have just R here, dr here, and this one here. Okay, I can write RO minus, oh, I need to find and change my variable. Okay, I need to change my variable to continue to solve this integral. Let me do it. If I name R minus R, RO minus R, power of 1 over n u, if I name this one u, this one me, okay, then 1 over n RO minus R with power of 1 n over n minus 1 dr equals du. Okay, if I derive it from these two terms, I would have this one. Then dr, because I want dr, is minus n r O minus R with power of 1 minus n over n. If you calculate it, you will have these terms. Okay, I suggest to do that, to write them and have these terms in formula. Then I want to continue, and I want to find R. Okay, and if I write things such as these terms, RO 1 over n minus R with power of 1 n, okay, it is U with power of n. If I put it, this is something like that one, okay, and I can understand that R will be RO minus U n. Okay, I have these terms. I am able to find these R from here, from this one. Okay, then sorry, from that one I can find these terms from this one, and this one from this one. Okay, I can find them and put it inside my integral to solve it. This is so important. Then let me continue. This is equals to we max RO with power of 2 n plus 1 over n. Okay, this is power of RO. Okay, here these two terms would be like this one, and some of them are the same. RO power of 1 and 0, because if I have, sorry, let me change the color. R equals 0 from this one, then U equals RO with power of 1 n. Okay, if I put 0 here, U will be something like that. If R would be RO and I put these RO here, the U would be something like 0. It will be 0. Okay, then let me continue. Then I can write RO minus UN du. Okay, if you put all of these dr, this one, okay, this one. This one is the R. If you put it inside that one, if you put R, this one, in place of that one, and in place of U, this is U. If you put U in place of it, and after a mathematical form, you will have this form. Okay, and do it to understand what is happening here. And after that, I will have such a this form, N and R O power of 2n plus 1 over n. V max. Okay, integral of r0 the power of rn to 0 r o u n. Okay, minus u to n du. Okay, then let me erase these ones because I don't need them. For rest assured, just pause the video and do it like me to understand what is happening. It is equals minus 2 and we max RO 2n plus 1 over n divided by RO n plus 1 u n plus 1, these power of u minus 1 over 2n plus 1 u and the power of 2n plus 1. Okay, from RO with power of 1 over n to 0. If I put 0 and R0 with power of 1 over n in place of u, because u is variable of integral, you will have minus 2n we max over RO 2n plus 1 divided by n multiplied by n 2n plus 1 n plus 1 multiplied by RO 2n plus 1 over n is power of this R. Okay, if you calculate all of these one, you will have this one, and it is obvious these two terms will eliminate each other. Okay, these two terms eliminated each other. Then I have V max equals minus 2n2 over 2n plus 1 n plus 1 V max. Okay, this was a solution for section 1 of problem. Thank you for watching. I have enjoyed to solving this problem, and be sure to calculate it by all yourself to understand all the problem and all the weak and power points of your ability. Thank you. Have a good time. Take care. Bye bye.